important concept. Remember, we talk about the rate of change is related rate problems. And the idea was we usually have a function, okay, function y, function f, and this is going to be, y is a function of x. So when you differentiate, you find the rate derivative. When y is a function of x, so you find the rate of the y respect to the x, whatever x is. But these x and the y, which are going to be coordinated of one point, if you consider at different times to be at different places, so this x is going to be a function of time, which is a function of t, and the y would be the function of t again. So x by itself is a function, but it's a function of t. So we can talk about x prime, or we say dx dt. So the dx dt would be the rate of the x. If you have y, dy dt, rate of the y. If you have z, dz dt, rate of the, okay, the z. So these type of problems are going to be called related rate problems. So the example that we discussed the other night and we didn't finish it was the cost function and the revenue function, okay? It was from your book and it was the cost of producing, okay, what? Manufacturing pet toys. So X is a number of the production. Production at different time would be different. So this is a function of T. So the rate of the production would be dx dt. Okay, that's a dx dt rate of the production. And then we have the cost and the revenue there. So for the first part, the question was if the rate of the production is going to be increasing at the level of 250 toys per week, we want to know what's going to be the rate of the cost, revenue, or profit. We talk about how we're going to set up these type of problems. You have to set up what is the given rate, unknown rate, and then you connect these variables together. So in this problem, the given rate was the rate of the production, 250 toys per week. The unknown one is the rate of the cost, okay, cost rate. So dx dt is missing, and you want it at the level of production of 5,000 toys. So you have to connect the c and the x together as an equation, and the equation is given to you. That's the cost equation. So that's going to be your equation. So what we do, we just differentiate. But the derivative is going to be derivative with respect to the x. So instead of saying c prime, you are going to say dc dt, the rate of the c respect to the time. So when we get to the other part, we differentiate as usual. Derivative of 75,000 is a number which is going to be 0, and derivative of 1.05x would be 1.05. But you have to multiply by the rate of the x, because there is a, okay, there is a function t inside the x. So that gives you dx dt. Now we continue. You substitute whatever you have. You see in this case, we have dx dt. So what we have is, just remind you, dx dt, we have it is 250. And we want it at the level of 5,000. And the dc dt, the cost rate is missing. Just substitute. So if you substitute dc dt would be equal to, you see equal to 0 is 0, it's going to be 1.05. Okay, and there is no x here. Times it by dx dt, and the dx dt is 250. 250. Okay, that's it. You just use your calculator to get this number. Okay, so this is what I have. I have 1.05. Okay, times it by 250. 250, I get 262.5. So it's going to be 262.5. So that's going to be the dc dt, the cost production, okay, the rate. So this is going to be dollars, it's going to be $250. $262.5. You have to give us a unit. So the unit was, okay, so the unit was producing toys, okay, and the time was week. So this is going to be 262.5. Okay, this is going to be toys per week. So that's going to be rate of change in your cost. So this means if you increase the production at the level of 250 toys, okay, per week, so the cost would be increased. The cost would be increased by the $262.5, okay, per toys, if you like. This is going to be the case. Okay. Any question? So this is going to be, in fact, the difference between these rates. So that's for the cost. We need to check the revenue. To check the revenue, you have to find the revenue function first. Okay. So the part B, we have to find the revenue first. So you know the formula for the revenue. Remember, revenue R is going to be equal to the X times P. So this is going to be equal to X times P. The revenue is already given to you, sorry. This is another problem I think about it. So the revenue is given is the 500X minus X squared over 25 is already given. Okay, so we don't have to find it, but usually you have to find it. Okay, so we set up the problem for the second part. For the second part, you want to set it up for the revenue, the rate of the revenue, Rx. Okay, the Rx is 500X minus X squared over 25. I'll double check this one. Okay, so this is a situation we're going to have. And the problem is going to be design again. So the design is going to be, you have the given rate as it's given to in the first part. It was rate of the production, the XDT. Again, we have 250 toys. Okay, toys per week. Then the unknown one in this case, okay, the unknown rate in this case is going to be revenue rate. Okay, it's going to be DRDT. You want to find it at what level? At the level of the X equal to the, okay, 5,000. Yes, that was 5,000. Yes, the level of the 5,000. Now you have to relate them together. So what's going to be your related equation? Equation that you're going to differentiate. Related equation. In this case, just the revenue R equal to the 500X minus X squared over 25. Any question?
Just a little bit, please.
That's it. Okay, so we have our function, the RT. So what we're going to do, we are going to differentiate this one. But differentiate respect to the inside variable. That inside variable is T. So differentiate, just for your information, with respect to the time T. So this would be just the rate of the R respect to the T, dr dt, instead of R prime, equal to the, this is going to be 500X, okay? You are going to differentiate it. When you differentiate the derivative of 500X would be 500. But remember, you have to multiply by the rate of the X, dx dt. Okay, there is a U prime all the time. Question? Minus, you differentiate this one, the derivative of X squared would be 2X. So it's going to be 2X over 25. But again, you have to multiply by the rate of the X respect to the T. Okay, so this is it. Any question? A substitute. DRDT is the missing one. The revenue rate. Okay, it's going to be the missing one, which is going to be equal to the 500 times dx dt, which is 250, minus, okay, 2x over 225. 2x, x is 5,000. Okay, it's going to be 5,000. This is 25. That's 25. And dx dt again is 250. Okay, you have to substitute for all these numbers to get your result. Now we have to simplify it. So this is going to be equal to the 5 times 25 with the 125 and the 3 zeros. Okay, and what is this one? It's going to be minus. We can simplify this one. By 25, this would be 1. By 25, this would be 10. Okay, then you multiply these together. This is it. 2 times, okay, 2 times 5 would be 10. So that's a 10,000 times 10, which is going to be 100,000. Okay, so 125, 100, so that gives you 25. So that gives you 25,000. Okay, 100,000 and 125,000. So the TRDT, the revenue rate, is going to be dollars. Okay, it's going to be $225,000. Okay, per week. So this is going to be dollars per week, if you like. This is going to be the rate of the revenue of, this is going to be dollars, if you like, per week. So that's going to be the rate of your revenue. So this means, again, if you increase the production at the rate of the 250 toys in week, your revenue would be increased by this rate per week at $25,000. Question? So that's the revenue to get these numbers. And they ask also for the profit. So it's going to be, they usually ask for one of them, but this is going to be one. How did I get 500 dxt? This is it. I differentiate. You differentiate 500x. You see, the div of 500x would be 500, but you have to multiply by the rate of the x prime. Rate of the x would be dx dt. Okay, it's a chain rule for all of them because there is a variable t inside each one of them. Okay.
Is the answer 125,000 or 25,000?
Which one?
The answer at the bottom. The dr divided by the dt.
This is 125,000. 125,000 minus 100. 25,000.
Okay, I thought there was a 1 next to the dollar sign.
No, it is all dollars. Okay, that's fine. Okay, any question? It would be given to you separately, but we have all of them in one setting. That seems to be a long problem, but it's not. Okay, so that's for the revenue. The part C, they ask for the rate of the profit. We have to find the profit function. Okay, so remind ourselves that this is it, and note that the profit function. Okay, the profit function is, remember, the profit is going to be a difference between the revenue and cost. Now, px is going to be whatever revenue you have minus c, the cost. You have to subtract it to get it. Your revenue is what? Is 500x minus x squared over 25. That's your revenue minus your cost. You have to open up the parentheses first and then bring the cost. Okay, so what was the cost function? The cost function is 75,000 plus 1.05x. 75,000. Okay, plus 1.0505x. Okay, now apply the negative sign inside to get your profit function. We call it P as it is in your book. So we are going to have, we have 500x here. Okay, minus x squared over 25. Then you multiply this one inside or negative sign. So that will be minus 75,000. Okay, and minus is going to be minus 1.0505x. This is it. Now we can combine the like terms. So it's going to be 500 minus 1.05. You subtract this one first and then you differentiate. Okay, so it's going to be equal to the p equal to, that's it. So this is 500. You see this is your 500 and you are going to take 1 point. Okay, this is it. You know, you can use your calculator. So this is what you have. When you subtract it, that give you what? And that give you 5, and that would be 9 and 8. Okay, that's going to be 8, 9, 4. You can use your calculator. It's going to be 498 point, okay, 0.95, 95x. When you subtract, you see, you take 1 out. This is it. You take 1 out, that give you 499, but you have a kind of a 5%. So this would be the result. Okay, so it's going to be minus x squared over 25, and then you have a number, 75,000. So this would be your profit function that you have to differentiate it again. Get the same thing that we did over there. Okay, I differentiate respect to the t because we already got everything we need. So you differentiate again. Okay, this is it. You are going to differentiate it, but make sure you do it with respect to the variable. Okay, variable time t. So the result again is going to be, it's not going to be per prime. It's going to be the rate of the p. So dp dt. That would be dp dt. Okay. When you differentiate this one, you drop the x, so that gives you 498.95. Just make sure you multiply by the rate of the x, dx dt. Anytime you differentiate, you have to multiply by the rate of the corresponding variable. The variable here is x, so multiply by dx dt. The next one is like the previous part that we did. The derivative of the x squared is going to be 2x over 25. And you have to multiply by the rate of the x, dx dt. Okay, and the derivative of 75,000 would be 0. Okay, any question? Now substitute the rate of change. The rate of the x again is 250 as we did it before, and the x is 5,000. You have to substitute, use your calculator to get this number. So it's going to be 498.95 times it by the rate of the x, which is 250. 250 minus again 2 times 5,000 divided by 25 times dx dt, which is going to be 250. It's going to be similar to the previous part that we did. Okay, so I have to use calculator to get this number. So it's both of them is like 25 times 25, 625, but you have to check it with the calculator. So I have 498.95 times it by 250. So that gives you something like, so this is going to be the result. It is 124,000. Okay, and 737.5. That is the first one. And the second one, as we did it before, is going to be 100,000. So this is going to be minus, okay, minus $100,000. Okay, so if you subtract it in this case, it's going to be very similar to the revenue that we did. So I put it on the top to finish it. So TPDT, the rate of the profit in dollars, okay, it's going to be what? It's going to be 24,737.5. So that would be the rate of your profit during those weeks. Okay, so that give you the idea, the type of application. As I told you, you can apply it in different situations, different conditions. But the one that we are going to be considering these are just the business functions, if you like. So the profit, the cost. So you get one of them in your next quiz or test, and that would be of these categories. Okay, just one of them. So that's a related rates problems. Any question? In application problems, some of them are very interesting and sometimes difficult to set up the problem. If you're building something from geometry, so you may have to know something in advance to be able to do it. But the way we applied in science, the situation would be described, the formula nicely would be given. You must know only the idea, that part that you have to differentiate respect to the t, and then get the substitution and your result at the end. Okay, any question? So that was the leftover of the last section of the previous chapter from, last lecture. Okay, ready for the next chapter. So what's the idea of the next chapter? In calculus or in science, problems that could be related. You see, you do something, if you're going to be money, you would like to have a maximum revenue, maximum profit, but a minimum cost, or in some other, procedure or process. So the problem of finding a minimum or the maximum values, we refer to them as optimization problem. Optimization problem, optimization is just part of the field, in computer science. So if you're going to be measuring on those courses, there is a course, we call it optimization, 400s course. Then you learn some numerical method in order to do it. But in calculus, we are going to do it in an exact form, if you like. So that's going to be the idea of this chapter. So it's going to be starting from section 3.1. Okay, we are going to talk about the maximum and the minimum. First, we have to define it. What do you mean by the maximum or the minimum? Okay, so this is going to be the definition that we're going to have. The expression that we're going to use are going to be relative, or sometimes they say local, relative extrema. Extrema means either a maximum or a minimum. Okay, relative extrema, relative maximum, or relative minimum. So we have to define it first. What is the minimum and the maximum? Now, when we talk about minimum and maximum of a function, we mean minimum and the maximum value of the function. In order to define it, you see, suppose you want to talk about, house prices. If you want to talk about the house prices, you are interested in what is the most expensive house, if you like, or the maximum price. What's the maximum price a house? So if you want to find this, you may think about your region. Okay, so what's the maximum price of a house in San Marcos? Okay, or the minimum one. If you talk about the San Marcos, it's local or it's relative. Okay, it's relative to where you live. So you may give us, a number, but you may extend it to the San Diego area. Again, it's a relative. California is a relative. But if you talk about the maximum value of a house in the entire country, in that case, you are talking about the entire domain. If you do it in the entire domain, we refer to it as absolute maximum. So there's going to be a relative one, which is a local, and there's going to be one, which is going to be absolute. And it's going to be the same for the minimum. So we are going to give you the definition of both of them. You let me know when I write this definition, when you have any doubt about it, because you have to live with this one through this chapter and through this course from now on to get this max ending. Okay, so let's pick the definition, make sure that you know, just provide whatever you want to do and then do it. So suppose you have a function. Okay, suppose a function f is given to you, okay, is defined on its domain, on the domain, whatever it is, domain D. So you have a function in its domain. Now pick a number in D. Okay, so it's going to be the one. Let a number, okay, pick a number that is going to be in D. Let C be a number. Okay, a number in D, in the domain of the function, okay. Now what I'm going to do, I'm going to define the relative maximum and the relative minimum, if you like. So the first part, I'm going to define the minimum first for you. Minimum value of the function means f of c. C is a number in the domain. F of c would be a number in the range. If this f of c is going to be less than the value of the function, it's a kind of a minimum. But I'm going to define relative and the, okay, absolute. So if this is going to be the case, f of c is called, okay, it's called a relative minimum, relative minimum of the function f, of the function f, if this is going to be a smallest value of the function, but not all the time. Okay, so that's a relative minimum if f of c is going to be less than or less than equal to value of the function f of x, but in our region only. For what? For all x near c. Near c, near your home. So it's like, you know, like in local. We call it the local minimum sometimes. So local minimum is it's locally, you know, in San Marcos only. So it's going to be called relative minimum if it's a small value, okay, or the value of the function is going to be greater than f of c, but only around the c. If you go to San Diego, everything would be different. So this is going to be the case. Now again, f of c, that's it. F of c is going to be an absolute minimum. Absolute minimum means it's a bottom of the function. Okay, absolute minimum. A minimum of f if you see it's going to be just the smallest value of the function. F of c is going to be less than or equal to the f of x forever. For all x inside the domain of your function. Entire domain is going to be entire country, United States of America, for example. That's the entire domain. So in this case, this is going to be called absolute minimum. So absolute minimum, that's the bottom of the function, bottom value of your function. But it's just going to be in the neighborhood of, you know, of your car, neighborhood of your home. It's just relative, it's local. Okay, any question? That's a minimum. Switch these directions of the inequalities, you get the maximum. Okay, we go with the maximum. That's it. So f of c is going to be is called or is a, you know, I already defined it, is a relative maximum this time. Maximum if now it's going to be greater than everything else. F of c is greater than equal to the f of x. Again, for all x in the neighborhood of c, near c. Near c. So that's going to be relative maximum or local maximum. And f of c now this time is going to be the largest value of the function. In that case, we call it absolute maximum. So f of c is an absolute maximum. Absolute maximum, so it's going to be the largest value in the entire country. So if f of c is greater than everything you think about it, you see, greater than f of x, but this time for all x in the domain. For all x in the domain of the function. That is the definition of absolute maximum and absolute minimum. And this is where we are looking for. Okay, we are looking to find these two numbers for you. Okay, when we say extrema means, you know, we mean a maximum or a minimum. So at the start, we find the extremum, but there are some tests that we check to see if this is going to be a maximum or a minimum. Okay, so I just remind you that, note that f of c is going to be is a relative extremum, if it is either a relative minimum, relative mean if you like, or a relative maximum. If we know it, if we know that there is a relative one, but in advance you don't know whether there is a maximum minimum, we refer to it as a extremum. Okay, extremum and extra for the polar form. Okay, any question? Your job is to find it. I give you an example, but the example is going to be used geometry for the time being. Then when we learn the theorems, that we are going to find it. So just a couple of graphs and these ideas. First one. Okay, so for the first one is, look at this one. You see, this is going to be the graph that we're going to be interested in is this graph. This graph is given to you. They identify this point. So this is a -1. And they identify this point for you. And this is going to be a positive one. Okay, so the graph ends up here. And they are going to identify this number for you. You see, if you like, this number here on the y-axis is 4. We want to know, what can you tell us about the maximum or the minimum of this value of this function? Remember, maximum and the mean are related to the value of the function. Value of the function is the output, is y numbers. And remember, the y numbers going up and down. This is y-axis. Okay, this is y-axis. Domain of the function is the input x. So for the domain, you go to the right to the left if you like. X. Or the range is going to be up, down. Okay. So for example, for this function, what's the domain of this function? Anybody can suggest what's the domain?
-1 to +1.
Excellent. You see how far you can go to the right, to the left. Because you need to determine the domain first for all these problems. So that's going to be -1 and +1. Okay, -1 and +1. So that's going to be the domain. Then you think about the values of the function. The value of the function is going to be on the y-axis. So as you can see, this function is, there is nothing below. Okay, everything is above the y-axis. So you have a 0 here, you see the 0 here because of the origin, and you go up. How far you can go up? You can go up to the 4. Because this is, this is x equal to the 1, the y numbers is 4. And over is going to be -1 and the 4. Okay, so this is your interpretation of the value of the function. Any suggestion for the maximum and the minimum? What is the smallest value of this function?
0.
Excellent, 0. That's it. And you get the 0 at x equal to the 0. Okay, 0. So your interpretation is going to be, you see, f of 0, which is equal to the 0. This is what? This is the bottom of the function. This is going to be the minimum of the function. But since you don't have anything else below it, so this is going to be is an absolute. Is an absolute. Okay, it's going to be absolute minimum. Absolute minimum because this is the bottom of your function. Anything everything else are going to be above it. So f of 0 equal to the 0 is an absolute minimum. And you got to be careful the way you are going to introduce this for us. We are interested in the value. So even if you say 0 is an absolute minimum, we accept it because that's the correct version. But if you want to talk about the minimum point is 0, 0, the origin. Okay, so just make sure when you get this one. So the minimum is 0. What's the maximum?
4.
4. 4 is the peak of your function. You see, you're not going to go above the 4. And how are we going to get the 4? You get the 4 at -1 and +1. So we can say that f of -1, which is equal to the f of 1 equal to the 4. Again, 4 is important, the maximum. This is the maximum value of your function. This is going to be is the maximum, or is the, if you like, absolute maximum of your function. Again, the value is important. You may get it at different points. It's like minimum wage. You get the minimum wage. Minimum wage, that's the formula. You see the $15, for example. But how many people can get that $15? Quite a lot. So the value is important for us, okay? So in this case, 0 is absolute minimum. 0 is absolute minimum. And okay, and the 4 is going to be absolute maximum for this function. Okay, so in fact, you identify the range of the function. The range of the function is going to be anything between 0 and 4. Okay, you don't have anything relative here because in both cases, we get to you reach to the maximum and the minimum value, and you are going to get it algebraically right away. Okay, so this is going to be 1. There is no f of 4 here, no, because it's just f of 1. 4 is the y value.
Yeah, I was just wondering, is it because is it equal to f of 1? Is it because they're at the same point?
Yeah, that's it. You see,
Okay.
1, 4, -1, 4.
Okay, thank you.
That's what we talk about. You see, you may get 4 is a maximum, and when we have several numbers that they reach to the 4. In this case, it's a -1 and 1. Okay, so in this case, we get the absolute max, absolute minimum. And that's very important. You will see in a minute that the reason that you get it is this interval. We are going to prove it later. That if you have a closed interval, you see closed interval. If you have a closed interval, if a function is defined as continuous, on a closed interval, this function would have always an absolute maximum, absolute minimum. We are going to investigate it later on. Okay, so let's change it a little bit. So I go to the next page to explain it. The change, let me just put it here because I want you to compare it together. So that's a number 2. So for the number 2, we are going to take out that restriction. Look at this one. You see, if they don't give you any restrictions, going up, 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 up. See this function? So this is not going to be restricted to the -1 and 1. Okay, because you can go to the right, to the left as you like. So in this case, the domain of your function, you see the domain of your function is going to be negative infinity and positive infinity. Okay, so what can you tell us about this one? This is the domain, but the value of your function, again, it starts from 0, you see. It starts from 0 from here, and it's going up, 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 up forever, because there is no restriction here, you see, because this go on and on and on. Do you have any maximum, minimum?
Would you have a minimum but not a maximum?
That's it, yes, correct, excellent. Yes, you have the minimum, the bottom, but you don't have any maximum. Some people say the maximum is infinity, but infinity, you know, we cannot get to the infinity. So this function would have only, you see, f of 0 equal to the 0 is going to be, is the absolute, is going to be the absolute minimum. You don't have anything else for this one. Okay, you don't have anything else for this one because you don't have the maximum. Because this function is, so look at the previous one. The previous one, you restricted the domain. When you restrict the domain, you get the restriction on the range. But over here, the domain is free. So we don't have any maximum or, okay, we have only the minimum. Any question? So we just, getting to know it, and then we are going to do it, find it. But the popular one is this. We get this one. This is going to be your function. Okay, suppose this is given to you. Okay, so at this point over here, suppose this is x is equal to 1, and this number over here is 3. This number over here is -1, and this number over here is going to be a -2. Okay, this is going to be your function. Let's see what can you tell us about this function. Again, the domain, you can go to the right, to the left as you like. So there is no restriction on your domain. So the domain of the function is negative infinity up to the positive infinity. Okay. Okay, anything you can tell us about this function? The max or the mean? Just think about it, how far you can go up, how far you can go down on the y-axis, or at what point. So Paul, maximum is 3, minimum is -2. You are almost right. What type of maximum the minimum is this? Is it a relative or is it absolute? In this case, yes, relative, Parker, you're right. You see, that's going to be one, yes. You see, this function would have a peak point, if you like. This function would be the peak point at what? At 1. So f of 1 equal to 3. F of 1 is equal to 3 is a maximum, but is not an absolute maximum. Because you see this function going up, 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 up forever. So you see, if you pick a number here, you are going to have something bigger than 3, bigger than 3, bigger than 3. So yes, f of 1 equal to 3 is a maximum, but is a relative maximum. Is a relative, okay, a relative maximum.
Professor, is
Yes.
the one supposed to be on the right side of the graph?
Oh,
and
yeah, thank you. Yeah, I missed that. You are right. Yeah, f of -1, sorry, you are right. This is f of -1 equal to 3. Thank you. Okay, so f of -1 equal to the 3 is going to be a relative maximum. It's not absolute because there are more numbers above it because this is going on forever. Then we get the minimum here. Okay, we get the minimum. Minimum is a -2. So f of 1 equal to the -2 is the minimum. Again, it's not absolute minimum. Why? Because if you say this is the bottom of your function, you say, oh, we have some points here. See, how about this? How about this? But for the time being, you know, relatively, if you forget about everything else, you see everything, forget about everything else around that. So f of 1 equal to -2 is going to be a relative. Okay, it's going to be a relative minimum. Okay, relative minimum, relative maximum. Any question?
Professor, so what do you say that when the domain is from -infinity to +infinity, we have relative maximum and minimum since we don't know where the function will be going?
Yeah, for this
Oh,
one.
and when we do have like a certain domain with like certain values, that's when we have an absolute maximum and
Yeah, if that interval is going to be close,
yeah, on both sides, correct?
yeah, always you get absolute max, absolute mean.
Oh, okay. Yeah, that's a good way
Yes,
to remember.
beside the relative mean and the max.
Yeah, okay.
But the important part is you get that absolute. Okay, so this convert. So to finish it, we have to declare that there is no absolute minimum or maximum, call it extrema. Okay, so in this case, we get the relative max, relative mean, but we don't have the absolute one. Any question? So if we understand, the definition, then when we get to the algebra part, we'll be fine. We have to make sure the difference. Okay, so that's going to be one. It's a relative because there are something else above it. You see, when we say absolute means the end. You see, this is not the end of the function 3 because the function is going up, up, up. So this is just for the time being in San Marcos. It's the same for this one because the domain is -infinity, +infinity. So you get lots of numbers here. You know that this function going down forever, you see, and this going up forever. So you cannot fix it to get the absolute minimum or absolute maximum. Okay, question? Now we need this last one. Look at this one, and then we relate them together, and we are going to find it. Yes, that's something higher than this one that gives you, the absolute minimum. This function is very popular, and we're going to see it. Look at this one. This is going to be a kind of, this is the version here. Then it's going up, up, Okay, this situation is going to be, we are going to have a number here. Okay, let's call it a -4. And there's going to be a number here. We call it a +4. This is going to be a -1. And this is going to be a +1. Okay, this point over here, suppose this is equal to 2. Is equal to 2. And this number over here, suppose this is equal to the 6. Okay. Let's check. What's the domain of this function? How far you can go to the right and to the left.
-4, 4 with a closed bracket.
That's it. So that tells you that you are going to have a maximum, absolute max and absolute min when we close it. Okay, now those numbers, the max and the min. Look at the situation for the function. There is nothing below the x-axis. So no negative numbers for the range. So the function is above. So above means you are going to start from the 0 for the y values. Okay, we get the 0 here. Then at 0, it's going to be equal to 2. Okay, you know that these are x-intercepts. You know, f of -1 is 0. F of +1 is also 0. So we get the 0 at these 2 points. Then you get the 2 at 0. F of 0 is equal to 2. And then you end up with the 6. You end up with the 6 because you have the 4, 6, and the -4 and 6. Okay, so these are the situation that you're going to know, you're going to have. Any suggestion for the max, min, relative, absolute? Get these numbers. Okay, Paul, absolute minimum of 0 and the relative maximum of 6. No, your absolute minimum is correct, but not the other one. Okay, any other suggestion? Just look at the situation they're going to. Yes, the minimum, you see the function is starting from the x-axis. So the value, the minimum value of the function is 0. We get the 0 at 1 and -1 intercepts. So we can declare that f of -1 is equal to the f of 1 equal to the 0. This is the bottom of your function. So 0 is what? 0 is the, okay, so this is the absolute, the bottom. Absolute minimum. This is done. Okay, because this is going to be the lowest value of your function that you know that you can have. Okay, relative maximum 2, which is correct. You see, forget about these 2 parts, the other parts. If you forget about these parts, you see, we have a peak here, we have a peak point. So the peak happened at, you know, it's going to be, the value is 2. So the 2 is going to be a relative maximum. How are you going to get it? You get it at 0. Okay, because 2 is on the y-axis. Coordinate of this point is going to be 0 and 2. So f of 0 equal to 2. You have to identify it. Where are we going to get it? F of 0 equal to the 2 is a peak point, but it's not the end of the function because the function is going up, up, up. So f of 0 equal to 2 is just a relative. Is a relative. Okay, it's going to be a relative maximum. Okay, that would be relative maximum. Anything else? We talk about the absolute minimum, okay, relative maximum. So what's the next number? Look at the function. Is there any end to this function or not? For the values. To the function, we get the ends where you are going to end up. Yes, you see that the 4, you see f of -4 is 6. f of 4 is 6. So the end of your interval, you see, the value, your value of the function, you see, start from the 0 on the y-axis up to the 6. 0 to 6. So the bottom is 0, the top is 6. So 0 is absolute minimum, 6 in absolute maximum. How are we going to get it? You get that 4 and -4. So f of -4, which is equal to the f of 4, and which is equal to this, equal to the 6, is the absolute. Okay, it's going to be the absolute what? Absolute maximum. And that's all the information that we get from this function. Eventually, you are going to do this one for us. It's a very nice function. It takes times to get it, but eventually we are going to get it, and we graph it over here. Any question? So this is how you compare these values together to get the relative minimum maximum. Yes, question?
Professor, I'm a little confused. Like previously you said when, like, because the other one went to infinity, so that's why you can tell it was relative. But then how can you tell from this graph that it does not go forever in like to infinite?
Because they restricted, you see. The end is given to you. You see, this function starts from -4 to the 4. So this means this is the starting point of your function, and this is the end point. You see, for the other one, it was not the case, because you have a negative infinity and positive infinity. So you're going up, 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 up forever. You see, there is no restriction over here for the ends. But this one is nicely restricted. It depends on the domain.
So you can't just like draw a line to find it on the x-axis?
No.
Okay.
That would be given to you. These are geometry, you see. The actual one, the algebra one, you have your function, the formula, everything. But this gives us a nice idea to see what's going on. This would emphasize that we better stay with this domain, closed interval. That would guarantee that you get a max absolute mean. And we have a theorem. We take care of it. Okay. So that gives you the idea of the definition that we're going to have, okay, for these relative maximum and the relative minimum to get these numbers. But the question is going to be, this is it, this is geometry. How about algebra? So how are we going to find them? Okay, how are we going to find them without graphing, of course, to get these numbers? So this is calculus. So what are you going to do? You have to relate each concept to the problem of the tangent line. Okay, because the tangent line is the one that we are familiar with and we know it. So look at this max and the min that we have. Okay, so if I just give you these conditions as a remark, if you like, as the remark is going to be, how are we going to find this maximum and the minimum? Look at this case, you see. This is where you get the maximum, now you know it. And this is where you get the minimum. So you check the situation of the tangent line. If you draw a tangent line here, you see it's horizontal. If you pick a tangent line over here, it's going to be horizontal. That's it. And we already talked about it, even on your test. What is the condition to get the horizontal tangent line? Remember, you get the horizontal tangent line. Since the line is horizontal, the slope must be 0. But the slope is f prime. So f prime, if you put f prime of x equal to the 0, find the x. Remember, these are the ones that are critical values. So if f prime of x equal to the 0, you may get the horizontal tangent line, and that would be the indication that you may get a maximum or the minimum. Okay, if you get this one, there is a possibility. There is a possibility that there is a, okay, there is a relative extrema at x. Okay, This is an option that we will to do it. Okay, so in this problem, f prime must be differentiable to be able to do it. Okay, that's the case one. Okay, but you may say, oh, that's nice, so I'm going to do it. No, you can't do it all the time. I give you this one now. Look at this one. Suppose your graph is this. You see, you have a sharp corner. Remember the sharp corner? You see, if you consider this one, at this point, this is the bottom of your function. So at this point, you are going to have a minimum. Okay, you are going to have a minimum. So what is the tangent line here? You see, since it's a sharp corner, it's impossible for you to keep a tangent line here. Okay, it's impossible for you to keep a tangent line because it's a sharp corner. The only possibility is this one. Look at this one. Some people, they say there is a tangent line, but that tangent line is going to be horizontal, if you like. Sorry, vertical. It's going to be vertical. So let's stay with the green one, vertical. If a line is vertical, do you remember what's the slope of a line? You know that the slope is how difficult it is to climb up, if you like. Okay, if the line is horizontal, no, it's not zero. It's going to be zero when it's horizontal. You see, when it's horizontal. You know that the slope is rise over run. Horizontal one, there is no rise. That's why you get a zero. But when it's going to be vertical one, there is no run. It's all a rise, which is very difficult. How are we going to climb this one? It's not possible. In algebra, when a line is vertical, we say that the slope is undefined. Remember? The slope is undefined, and in calculus, we say the slope is infinity, if you like. So the difficulty here is you cannot rely on this one, f prime x equal to 0, because there is no f prime. There is no f prime, but there is a minimum. So you have to add this one to your collection, that if f prime of x, okay, if f prime of x does not exist, like this one, it's vertical, does not exist, it's undefined. If f prime of x does not exist, then there is a possibility that you may get the minimum or the maximum. Okay, so there is a relative extremum or extrema at x. So it's exactly the same that we look at this one. If you take this one, at this point, you get a horizontal tangent line, but these are the sharp corners. At the sharp corner, you cannot have a tangent line. You have the vertical tangent line. But you know that f of -1, f of 1 was what? Minimum. And f of 0 equal to 2 was a maximum. So there is a possibility. Okay, there is a possibility that at this point you may be. So these are the only places that you have a chance of having a maximum and a minimum. Okay, but it's not guaranteed. So what we are going to do for the rest of this chapter is we are going to collect these points. The first one, that's why I was just giving you this problem all the time. So before getting, these are the possibilities only. There's no guarantee that you will see it. So since they are possibility, these results, okay, these numbers, we call them critical numbers or critical values. And this is going to be your first job. If you want to find the max and the mean, the candidates are critical numbers. What's critical numbers? You solve the equation f prime of x equal to 0, you collect these numbers. Or if f prime does not exist, you identify, you collect these numbers together. These are the candidate for the max and the minimum. And then that keep it going. So that would be our roadmap, if you like, for the rest of the chapter. We are going to introduce this as a definition. Okay, there are some theorems involved that we don't need it. We can quickly get through it. So We introduce this as a point, but the difficulty is when we find it, we may get, we may get a maximum or we may not get a maximum. So we need some other test to identify whether you have a maximum, where you have a maximum or the minimum. There are a couple of tests that will take care of it, and then we'll be finished with this one. I give a break. We come back and we start it. So that was the roadmap. I introduced the point that satisfy this condition. I call them critical numbers or values. Okay, critical numbers. Your book call it numbers. I call it values, but I stay with your book. And then when you find that they are the candidate, and you can go and determine it's the maximum or the minimum. Okay. It's 8:25. 10 minutes, we come back and we start the job. That was just a definition. Okay, any question? See you in 10 minutes. Okay. So we are going to make this one official. Okay, that's a great theorem. And, the observation that you saw it from, these pictures, but this was done. It can be proved. And I teach calculus 1, 2, 3, I prove it. So it's a theorem by Fermat. So we write it down and then we get the conclusion and we keep going. Okay, make a record of this one, theorem. And that's exactly what we talk about it. Okay, that's Fermat or Fermat, great French mathematician. Okay. Fermat has done quite a lot in other fields, but it's popular for, for the calculus too. Okay, exactly the thing that I did. So we make it official that if a function, okay, if a function f is going to be continuous, you need continuity. It's continuous. Okay, continuous on the closed interval of a comma b. Okay, and we have a, and c is a number. Okay, it's going to be a number inside this interval. Inside, okay, the interval of a comma b. This theorem cannot be used for the endpoints. Okay, that's why we make it open, such that, okay, such that f of c is a relative maximum or a minimum, relative extremum. Okay, such that, change this pen. Okay, it's going to be a relative extremum. Then there are two possibilities only. Then there are two possibilities. The possibility is f prime of c is equal to the 0. So this means you get a horizontal tangent line, or you get a vertical tangent line. F prime of c does not exist. Okay, this is the two observation that I talk about it. I just repeat it again here. And this case is going to be in this form. Okay, this is the case that you get a horizontal tangent line. And you know that when we get a horizontal tangent line, the slope is 0, f prime of c is 0, like the one that you did on your test. If you want to have the example of this one, this is where we get the sharp corner one. You see that's a sharp corner. If we get a sharp corner, your tangent line is going to be vertical. You see, this is going to be vertical. When it's a vertical, f prime of c is very difficult. Does not exist. Okay, so this is observation, and it can be easily proved to get the, to get these numbers. The page, that is it. Okay. So that's going to be two observations that we are going to have. Nicely can be proved by the definition of the limits. So any case that you consider when you get a maximum and minimum, you may get the maximum minimum on these points. So in this case, f prime of c is 0, or you may get a sharp corner. Okay, at the sharp corner, f prime of c does not exist. So these are the candidates only. Okay, it's not the case that, if f prime of c happen to be 0, there is a guarantee that you get a maximum or a minimum. Okay, so what we are going to do is we are going to pick these candidates and we give it a name. Okay, the name is critical numbers. critical numbers. I refer to it as critical values, but both of them are the same. So on those practice one, take home one. If you see critical values, because the book that we teach at the university, it's called critical values, but they are the same. So that's your tool for the rest of this chapter. And you have to find it for us, okay? So are you ready? What is a critical number? It's a number that satisfies these two conditions. Okay, these are going to be the one that we are going to have. Are you done with this definition? So let's see what's critical value. So suppose a function is given to, let's move this one a little bit. So the definition is, suppose, okay, a function f is defined, we need a domain. Okay, is defined on the domain, its domain, okay, domain D. So this means for all this problem, you have to determine the domain first. Okay, it's going to be the one. So if this is going to be the case, okay, a number C in the domain, C in the domain D. So the first condition is this C must be in the domain. A number C in the domain D is going to be called, okay, it's called a critical number. A critical number, or sometimes I may call it or critical, okay, critical value. Okay, so a number C in D is called a critical number or a critical value if two conditions. If either f prime of C is equal to the 0, means you get a horizontal tangent line, or f prime of C does not exist. Because these are the candidates according to the Fermat theorem. It's not the case that they are going to be maximum and the minimum, okay? But there is a possibility. So this means if there is one, it must satisfy either, okay, or these two conditions that we're going to have. Okay, so the result is going to be called a critical number. So you are going to be asked to find it. So you differentiate, you let it equal to the 0. You may get something from here. Or sometimes you differentiate, you find out f prime of C does not exist. You have to collect those numbers too, okay? Two sets of problems or numbers. Any question? So and that's your job, you have to find it. We are going to have something like, I usually have 7 types of functions, okay? But you are not going to have trigonometric functions, so a couple of them would be dropped. So eventually it's going to be something like 5 different functions that you are going to deal with, okay? It's 5 or 7. We cannot give you 2 of those functions. We talk about it next chapter, chapter 4. So we are going to focus on the rest. Any problem in this course are going to be one of the following functions. The first one is polynomial. The second one is rational function. The third one is the radical function. Okay, so for the time being, polynomials, rational, radicals. Then when we get to the chapter 4, we get 2 more functions, exponential function and the natural log function. These are going to be your tools. So you have to have them around for all the other problems that we're going to do in this course, okay? In your case, it's going to be most of the time is a polynomial, in your field. But if you are going to be, measuring engineering, physics, so you need trigonometric functions, sine, cosine, tangent, etc. Okay, so your job is easier but make sure you know you are able to do it. So let's do it. Are you ready? Example. It's your job. Find the critical numbers. So would like you to find. You get one question. Okay, and you get all these three functions. And for the other questions, indirectly, you are going to find it for us. Okay, would like to find all critical. Okay, find all critical numbers or values. Numbers of each function. For the first group, you already done it. You know, you haven't done the radicals, but everything else we already fix it. We didn't call it critical numbers. Remember, we asked you horizontal tangent line. It's the same thing. So the first group, polynomial, most of the time. So we go with this one, f of x equal to, I have 2x cubed, okay, minus 3x squared, okay, 3x squared minus 36x, okay, minus 36x plus 14. That's type 1 polynomials. Okay, so it's similar to your quiz. A couple of you missed the quiz, this problem. So go back, check your solution, make sure you have no difficulty to apply it, to apply it again. So this is it. This is how we're going to do it as we did for the other one. You must start with the domain, okay? Because you have to make sure that these numbers are in the domain. So make sure don't miss any point. Solution, domain of this function. What's the domain of this function? Domain.
Negative infinity to positive infinity.
That's it. It's a polynomial. So the domain is R or negative infinity, positive infinity. That's a step 1. Okay. Step 2, differentiate let equal to 0. This is a polynomial, and Charles, you are right. Okay. So what are you going to do? You are going to find f prime. Carefully differentiate it, which is easy. 3 times 2, 6, x squared minus 6x minus 36. Double check, make sure your derivative is all right. So the function is differentiable. So you have only case 1, you see, 2 cases. F prime of c equal to 0 or f prime of c does not exist. You are not going to have the second part. So let it equal to 0. F prime of x equal to 0. Solve this equation. 6x squared minus 6x minus 36 equal to 0. Factoring. The common factor is 6. We pull out the 6. X squared minus x minus 6 equal to 0. Carry on, factor it again. You need 2 numbers, product of 6, difference of 1. Okay, and this is going to be 6 times that by, it's x minus 3 times x plus 2. Again, double check this, equal to 0. 2 times 3, negative 6, and negative 3 plus 2, negative 1. You let each factor equal to 6 equal to 0, never, because that's a number. X minus 3 equal to 0. That gives you x equal to 3, one solution. X plus 2 equal to 0. X equal to negative 2, the other solutions. Critical numbers, Cn, are going to be negative 2 and 3. And you're done. Any question? So for the time being, we just identify it. But then we learn some methods, because your job, your next job is going to be, you drop them back into the function. Remember, because for the max and the mean, it's a maximum value and the minimum value. So you drop it back to the function, you find f of negative 2 and f of 3. Then you have to test it. You have to tell us which one is the maximum, which one is the minimum. We're going to learn 2 different tests to check it, okay? So it's going to be more to do, but for the time being, we are just checking the critical numbers. Any question? So for the critical numbers, you're done. You are not going to do anything else for us. Okay, and that's a type 1 polynomials. Most of the time, your case are going to be polynomials. But we need some more. Okay, that's type 1. Type 2, rational function. Okay, there you are. We get the type 2, and you already check all these in your previous quiz. You are ready for it. Remember this type of function? I told you. You are going to use it. X over x squared plus 60. Rational function. The rational function are these categories most of the time. Okay, to get the true. Okay, you have to start with the domain. What's the domain of this function? You know, the rational function, you have to check to see if the denominator can be equal to the 0. That's x squared, and you have the x squared plus 16. Domain or real numbers. Yes, you are right. All, null, that's it. Yes, we check the denominator, x squared plus 16 is not factorable. Remember, you can factor x squared minus 16. When it's not factorable, nothing to worry about. You're not going to have any holes. Okay, so the domain is going to be all real numbers. Okay, so the solution is going to be, remind you that x squared, you don't have to write it down for the test, is not factorable, and so it's never 0. You know that when the denominator is not 0, so the domain of this function is all real numbers. Remember, you need the domain. You will see when I get to the case 3, you find out why these are very important. Okay, now differentiate. To differentiate, only quotient rule. Lift up the top times bottom, bottom to up. Okay, you are not going to move it up, just quotient rule. So apply the quotient rule. F prime of x equal to quotient rules. Lift up the top times bottom. Lift off the top, lift of x is 1. So it's going to be 1 times x squared plus 16. That's the lift of the top times bottom, minus lift of the bottom times top. Lift of the bottom would be 2x. 2x times top times x. Divided by the bottom square. X squared plus 16 all squared. Okay, carefully differentiate it. So you know that you have to go on, simplify the top, and you let it equal to 0. So it's going to be equal to. So we distribute the one that gives us x squared plus 16 only, minus 2x squared. And this would be x squared plus 16 all squared. Okay, continue on the top to simplify the like terms. You have the x squared minus 2x squared. So that gives me negative x squared. So equal to negative x squared, okay, plus 16. And divided by x squared plus 16 all squared. That is going to be a F prime. Okay, I rewrite it for myself again. So this is going to be F prime. Negative x squared plus 16. And I have x squared plus 16 all squared. Okay, you let it equal to the 0. Equal to the 0. We already talked about it. A fraction is 0 if only the top is 0. Because for the fraction, it's 0 divided by 2 would be 0, like the one in your test. Okay, so you let it equal to 0, the conclusion is going to be the top is 0. So we get negative x squared plus 16 equal to 0. Any question? So we have to solve this equation. You know the different way to do it. You can move the 16 to the other side, okay, and then take the square root, or you can factor it, okay. You know, both of them are going to be possible. So I move the x squared to the other side, make it into the, okay, make it to the x squared equal to the 16. Okay, and you take the square root, So x would be a positive -4. That's it. So we have two critical numbers. So the critical numbers are going to be a -4, 4. And these are going to be the possibilities. Any question? So for the rational function, you have to go through the, okay, you have to go through the quotient rule. You go through the quotient rule, nicely differentiate it. Be careful when you simplify it. And at the end, you get the final answer. Okay, I'm going to give another one for the quotient rule. Make sure that you understand it. Any question? So again, the next step is going to be later. We drop it back into the function. We get the f of 4, f of -4, then we test it. And eventually we'll find out that one of them is going to be given as the minimum. The other one would give us a maximum. Okay, any question? So that's a number 2. Let's try number 3. Number 3, again, the quotient. I just want to make it a little bit more involved so that make sure that you have no difficulty in applying the derivative. And this is it. It's x squared minus 2x plus 1 on the top. Okay, and the x plus 1 down the bottom. This is going to be the function that you want to check, this one. Okay. Then what we are going to do, we have to determine the domain first, okay? And then we go for it. Any suggestion for domain of this one? Again, is a rational function. Yes, checking this. There is a, okay. So this is, just want to check something in your book. Make sure you get to the order of your sections is a little bit different, but you will get it. You have the critical points over here, all of them. Okay. So the domain denominator we check, you know that the denominator would be 0 at -1. Yes, sure, you're right. So this function is defined everywhere except at -1 because of the denominator. Okay, so solution is going to be solution. We know that we have to take out the -1. Okay, so we take out the -1. So the domain of this function is going to be negative infinity going to the -1, union with a -1 and positive infinity. So that would be domain. You need the domain. Domain for all of them. Okay, now we have to find the derivative f prime and then let it equal to 0. So we go with the quotient rule again, f prime of x is equal to, if the top times bottom, the top would be 2x minus 2, 2x minus 2. You have to put it inside the parentheses and you multiply by the bottom, x plus 1. Again, that's if the top times bottom minus. If the bottom times top, if the bottom one, of course, is 1 times top. So I write it down so that I keep the parentheses for this negative sign. So it's going to be 1 times the top, which is x squared minus 2x plus 1. That's if the bottom times top, of course, divided by the bottom square. That's it. Again, you have to continue on the top, distribute it, simplify it, and then let the result to be equal to 0. There is a negative sign here that you have to apply to all the term, and of course there is a FOIL method that you have to apply. Okay, so apply the FOIL method, nicely simplify it, FOIL it, 2x times x, 2x times 1. So that gives us a 2x squared plus the 2x. Then you apply the -2 inside. So it's going to be minus 2x, okay, minus 2. Then you have a negative sign here, so that gives you negative x squared. Okay, plus 2x minus 1. Okay, and we have the x plus 1 all squared. Continue, combine the like terms. So it's going to be equal to, okay, let's see what we have on the top for the x squared. We have a 2x squared minus x squared. So I take care of these two first. So that gives 1x squared here. Okay, the x's, positive 2x, negative 2x would cancel out. So we end up with a positive 2x plus 2x. And the numbers are negative 2 minus 1, which is going to be negative 3. Okay, divided by x plus 1 all squared. So this would be f prime of x. Okay, so when it's a rational function, be patient and carefully differentiate it. Now let it equal to 0. 0. When it's going to be 0, the top would be 0. So the top is x squared plus 2x minus 3 equal to 0. Now we have to factor it. You factor it, it's not difficult to factor. Two numbers product of 3 is going to be 1 and 3. So it's going to be x plus 3 times x minus 1 equal to the 0. Two factors equal to the 0, x plus 3 equal to the 0. Okay, x plus 3 equal to the 0. That gives you x equal to the negative 3. And x minus 1 equal to the 0. That gives you x equal to 1. There you are. We have two critical numbers. Critical numbers are going to be a negative 3, comma 1. And then we're done. Okay, it's a quotient function. I just give you something a little bit more involved because these are the categories that we have. So we have to get used to it and take care of it nicely. Be careful when you simplify it, so that if the result's getting something, complicated, something that you cannot factor it or factoring badly. So this means probably you missed something. Go back and take care of it. Okay. Any question? So that's the second group. The second group are going to be rational function. Now, the tricky one is the third group. Okay, remember the definition of critical number was two-folded, if you like. The case that f prime is equal to the 0, which has happened for all of these, or the case that f prime is undefined. The case that they get a vertical tangent line. We didn't have that so far, but you are going to see it in a minute, okay? So what's a rational function? Radical function. There are kind of two categories of these functions, but they are going to be important in application. So this would be our, 1, 2, 3, 4. That's it. So the fourth one is this function. Look at this one, f of x equal to, suppose we have f of x equal to what? Something like the fifth root. Okay, it's going to be a fifth root of something easy, x minus 9. We want to find the critical number for this function. It's a radical function. Okay, we have to start with the domain. What's the domain of this function or the radical function?
Negative infinity, positive infinity.
Excellent. Because you see the index is odd. They mostly give you odd index over here, okay? So yes, Paul, you're right too. So the important part is the domain solution. Just remind you, just you don't have to write it down on the test, but remind you that the index 5 is odd. Especially for this one, you will see in a minute that how important the domain is. So the domain is going to be negative infinity and positive infinity. Okay, very good. Now you have to differentiate it. You know that to differentiate this function, we have to rewrite it. We have to rewrite it. Okay, so we rewrite f of x equal to, it's going to be x minus 9. X minus 9 to the f5th, to f5th. Okay, that's it. Then in order to differentiate it, you have to use the chain rule because it's going to be u to the 5th. Okay, so we apply the chain rule, which is going to be f prime of x equal to, remember the power down, f5th, x minus 9 to the 1/5 minus 1 is like 1 minus 5, it's going to be -4, okay, -4/5 times u prime. U prime derivative of the inside, which is 1. Okay, just to remind you that you have to use the chain rule for this group. You see, remind you this formula that I use. So I bring down the power, it's going to be a 5th, u to the -4/5 and the u prime. So that's a formula that we use. Okay, now we have to continue because we want to let it equal to the 0. So first thing to do, you have to get rid of this negative sign. To get rid of negative sign, you know that you write it on the fraction form. Okay, so this is going to be your f prime. It's going to be a fraction. On the top, we get the 1. Down the bottom, we get the 5 times x minus 9, everything to a 4/5. Okay, this is the algebra part that we have, we have to do it. Okay, so that's u to the 1/5. It's going to be 1/5 minus, okay, 1 minus 5, which give you the, okay, give you the 4/5 to get the 1. U prime is chain rule. U prime, that's the formula for the chain rule. U prime derivative of the inside, derivative of x is 1. Derivative of 9 is going to be 0. Okay, so that's going to be our f prime. Now we let it equal to 0. If you let it equal to 0, what's going to be the result? 0. You see, when you let it equal to 0, the top must be 0. At the top is 1. Okay, so the top would be 1. 1 equal to the 0, which is impossible. Okay, so we get no solution. We get no solution when you put the f prime equal to the 0. Okay, so from this case, you are going to have, there is no solution. And most of the people, when we get to this part, they say there is no critical number, which is not true. Now, for these type of problems, as soon as you differentiate it, there is a reward that you have to collect it. What is that reward? Look at this function. What is the domain of this function, f prime? Any suggestion? Remember, it's a rational function. Okay, so when we start with the f, it was a radical function. The domain of that radical function was all real numbers. But when you find the f prime, you change it to the rational function. You know that a rational function is not defined when the denominator is 0. So you check to see for which value of x this denominator would be 0. Any suggestion?
9.
9. Very good. So when you put x equal to the 9, f prime of 9 does not exist. Remember, what does it mean? F prime is the slope. When we say f prime of 9 does not exist, you mean that you are going to have a vertical tangent lines. Remember the definition of the critical value? There was 2 parts. Look at this one. The situation is that f prime of c equal to 0. You get this one for all the other problems. Or f prime of c does not exist. Sharp corner. For this radical function, most of the time, you get this situation you're going to have. Yes, you let it equal to 0, you didn't get anything. But you have to explain it. You say, oh, bad. F prime of 9. 9 because if you put x equal to 9 here. F prime of 9 does not exist. Does not exist. And you have to check x equal to the 9 is in the domain of the function. Because sometimes this number may be not in the domain of your function, so you throw it out. But f prime of 9 does not exist, and x equal to 9 is in the domain of the function. And that was the second part of the definition of a critical values. You say f prime of 9 does not exist, x equal to the 9 is in the domain of the t, and so it is a critical number. X equal to the 9 is going to be what? Is a critical number. Critical number. So you have one critical number. You see, that's a situation you're going to have. So you got to be careful for this radical function. We call them free. We say this is a free critical number. You didn't see anything, do anything and you get it. So when you get this part over here, you're not done. To say that there is no solution. Yes, there is no solution for the first part. F prime of x equal to the 0. But since it was a radical function, you change it to the rational function and you have this f prime of 9 does not exist, and you have to guarantee that this is in the domain of the function. Okay, it is in the domain of the function, so it must be a critical number to get this number. Some people, when I do this one, they take me back to this example that I did. Look at this example that I did for you. Look at this one. Some people, they say, oh, how about this one? You see, this is the f prime. F prime of -1, f prime of -1 does not exist because the -1 makes the denominator equal to 0. And some people claim that f prime of -1 must be a critical number. But there is another condition. F prime of -1 does not exist. -1 must be in the domain of the function. What was the domain of function? Look at this one. -1 is not in the domain of your function. So that's why we don't consider it. We don't consider this argument for the rational function because this point is already out. But for the radical function, you see, for the radical function, your domain is all real numbers, okay? So your domain is all real numbers, so x equal to the 9 is in the domain, and okay, and does not exist means you get a vertical tangent line. So in this case, you get one critical number. So this is the point that you must make sure you understand it and be able to apply it for us to get okay, to get these numbers. And this is going to be a situation gap. Any question? No. You just give me a couple of minutes because we change it a little bit. We make it a last example. Let's see if you can tell me what's the difference. So this is a change a little bit. This result is a very popular function. We have already talked about it. Look at this one. What I'm going to do for you is I keep the 5, but I change the x into the x squared. Let's see what's going to be the difference. Okay, look at compare the solutions. We start with the domain. Domain would be the same. Okay, because the index. So let's do it to see where they are going to be different. So that can be the solution. Again, your index is odd. 5 is odd. And so your domain is the same thing. Negative infinity, positive infinity. Switch it. So rewrite it. That gives x squared minus 9 to a fifth. Differentiate. Same thing, u to a fifth. So what's going to be derivative? F prime of x equal to, you bring the power down, f fifth, x squared minus 9 to the f fifth minus 1, negative 4/5 times u prime. This is the difference. What's u prime for this one? Any suggestion? U prime?
2x.
2x. You see, u prime would be 2x. That's the difference. Compare it with the other one, you see, the other one, u prime was 1 because u was x minus 9. In this case, u prime is going to be 2x. Switch into the fractional form, f prime of x equal to, get a fraction. Now you see on the top, we get the 2x on the top. You get the 5 down the bottom times x squared minus 9 to the 4/5. Okay, we let it equal to the 0. Compare. You see that was 1 equal to the 0. You didn't get it. But this is not 1. It's what? We get the 2x equal to the 0. You know that 2x equal to the 0, x would be 0. So that gives you one critical number. Okay, one critical number, but you have to collect that free one that we talk about it. So what's going to be the free one this time? You check to see for what value of x the denominator would be 0 this time. Any suggestion? For what value of x the denominator would be 0? The denominator would be 0 at 3 and negative 3. Yes, Charles Paul, you're right. The denominator would be 0 at 2 points this time, positive or negative 3. And both of them are in the domain of the function. So this means you are going to have 2 vertical tangent lines if you like. Okay, so you have to make sure to get that one too. So, oh, also, okay, that's it. Also, f prime of negative 3 and f prime of positive 3. Because the number 0 at 2 points do not exist. And you have to make sure they are in the domain and x equal to the positive negative 3 are in the domain because the real numbers are in D. Are in D. So both of them, x equal to positive negative 3 are critical, are also critical numbers. So what's the conclusion? You have 3 critical numbers. Critical numbers are going to be negative 3, 0, and 3. So you are going to have 3. This is the most, not tricky one, usual or unusual problem of this section that you have to know it. I've given this one similar one several times on the test. Most of the people, they missed it. They just give me only 0. It's not. When it's a radical function, there is a reward. The reward is when you let the denominator equal to 0 for the f prime. There was a vertical one that we're going to have. And that's the kind of graph that we know we did it. You see this graph, remember? The one that I talked about it. If you graph it, that's give you the result. Look at the horizontal tangent line. You have the horizontal tangent line here. You have 2 sharp corners. So this is the sharp corner at the negative 3 and 3. These are the sharp corners, so your tangent line is going to be, okay, vertical. So that's why we get 2 out of the does not exist here, and 1 from the letting the f prime of x to be equal to the 0. So that's the third case. There are 2 more. We get it in chapter 4. The way your book is going, they talk about everything. Then they come back to the exponential function and the log function. So then we get it as a 5 function. So through this chapter, we are going to use these 3 functions, in any of the coming problems that we have. And that's it. We are at the position that We find the candidates. Okay, these are our candidates for the maximum minimum. The next question is going to be, which one of these is going to be relative maximum, or which one is going to be relative minimum? There are a couple of methods, we call them tests, to check it. One of them use the first derivative of the function, we call it first derivative test. The other one use the second derivative. Remember the second derivative, we talked about it. We call it second derivative test. And it takes times to be able to know to finish it. So you have to wait to be able to do some of these problems. But for the time being, just study this one and the critical values. By then we are going to talk about on Tuesday. So we need a Tuesday and the Thursday next week to be able to finish these two tests. And then we are able to find the maximum and the minimum of the given function. So that was the roadmap. That's it. Any question? So read these examples carefully. The algebra involved, especially get to know these radical ones so that you are not going to lose any point. But your book is a polynomial type. Almost all the problems are polynomials, but there is